Proxmox VE is a very popular open source hypervisor, and since version 8.1, the SDN core packages have been installed by default. Now, there are various benefits to be had from software-defined networking, but one is the ability to create an overlay on top of the physical network. This allows you to create virtual networks, allowing virtual machines on different nodes in the cluster to talk to each other, but without needing changes to the underlying physical network. Now, that may not sound like much unless you've worked in IT, because just adding a new VLAN, for instance, can require a lot of planning and preparation. Multiple changes will need to be made on several devices, and if a mistake is made, it can bring down the entire network. But even with automation, in large companies, it might still be a while before these changes can be implemented due to change control. So how do you set up VXLAN zones in Proxmox VE to simplify network design and make your IT services more agile? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is specifically about SDN, I'm going to assume you already have Proxmox VE installed. If not, then I do have another video available which shows you how to do that. I'm also going to assume that you have a cluster built, because really there's no point setting up VXLAN zones on a single server. If you don't know how to set up a cluster, then there's another video I have made to help you with that. And lastly, I'm going to assume your servers are running at least version 8.1. But if you do need to upgrade from version 7, then yes, I also have another video to show you how to do that. Now, the first thing to do is to make sure that the servers are ready to actually support SDN. Now, over here on the documentation, it's saying that the core SDN packages were installed by default, starting with version 8.1. Now, if I go over to my actual cluster here, we're running 8.2.4, but all of these actual servers were upgraded from 7 point something over the course of time, and we're actually seeing this SDN section here. So this doesn't just apply to brand new installations. Even if you've actually upgraded, you're getting that software installed. All the same, it's saying that if you've upgraded from an older version, make sure that this libpve-network Perl package is actually installed on all of your nodes as well. So back over here on the cluster, I'll pick one of these out. I'll open up a shell session, but you could just remotely access them through SSH instead if you like. We're first going to run apt update, because basically what I want to do is just make sure that all the packaging information is up to date. So hit return, off it goes. Okay, that's ready. And then we want to make sure that that actual software is actually installed. So just hit return. Now in my case, it already has the newest, latest version of it, so it's already installed, so that's fine as well. Now, it's also warning you that it's only since version 7.0 that the if up down 2 package has been installed by default. So if you've actually got an older version and you've upgraded that over time, then you want to make sure that that's installed as well. I'm going to assume that the majority of versions are after version 7.0. So we'll move on to the next setting here, where it's saying make sure that the network config file is actually up to date. Basically what it wants is this line here included, because the way this works is it doesn't modify the main configuration file. It actually puts files into this folder. Now, okay, so far I've actually only found one actual file in there called SDN, but they're using a wildcard to include any file, so we want to make sure that we're ready with that as well. So back over here on our server, what I'm going to do is to use nano to edit that actual config file. Now I don't have that line anywhere here, so I'm just going to go up to the end and I'm going to copy and paste in that line, so that basically when this config file gets read, it'll include any files within that actual folder there as well. So let's save that change. Back over on the actual documentation here, That's basically as far as I need to go. However, for extra measure, I'd want to reboot the actual server, and I'd want to repeat this process for all of the actual servers that I've got in the cluster. I say that's only as far as I need to go because these two packages here don't apply for VXLAN. There's DHCP-IPAM, which currently it's saying is an opt-in, and so far that DHCP support only works with simple zones, which we're not using. Because it's an opt-in and it's in tech preview, then it's not actually supported. The SDN core packages are fully installed by default and they are fully supported, whereas this isn't. The FR routing or routing package, that's more for the advanced layer 3 solutions. Again, it's an opt-in, it's in tech preview, and it's not fully supported. So again, this isn't something you'd want to put into a production environment. So yeah, as far as VXLAN goes, all we're interested in really is this bit here. So I'm going to upgrade all of my other servers, reboot them to make sure they're ready, and then we'll proceed from there. Now, when it comes to configuring software-defined networking on Proxmox VE over here, we don't go to each of these individual servers and configure this. Instead, we do it at a global level. So you go to data center, and then we've got our SDN section. So you'd set up various options within here, and then what it'll do is then push all of the changes out to the actual server. So that makes manageability a whole lot easier, less likely for a configuration mistake and so on. So the first thing we need to do is to create a zone. So underneath SDN, I'm going to select zones, click the add drop-down menu, and we've got choices of simple, VLAN, Q&Q, VXLAN, and EVPN. So for this video, what we're going to be doing is to set up a VXLAN zone. So select that. Now, one thing to bear in mind about this is that we're going to be using tunnels. That's what VXLAN involves. What's going to happen is that the virtual machine traffic is going to be put into a tunnel, and then one actual server will send it across to another server, and then the traffic will pop out of that actual tunnel and go directly to the actual virtual machine that it's destined for. That gives you a lot of flexibility. It means that your actual servers here, they can all be in different subnets, they can be in different locations. So that's extremely useful because it means that you could have your virtual machines in the same layer 2 network, even though your actual hypervisors aren't. They could be in different locations. It won't make any difference. Your virtual machines will still be able to talk to each other at layer 2. But it means that you can set up all of these virtual networks within Proxmox VE here, and you won't have to make any underlying changes to the physical network, as long as these servers have got access to each other. And in the case of VXLAN, we're using UDP port 4789. That's the one key thing you need to bear in mind, is that if the actual traffic between these servers goes through a firewall, make sure you're allowing access to UDP port 4789. In any case, when it comes to setting up a VXLAN zone, we need to fill in various information. So I need to give this a name or ID, so I'm just going to call this test. Now, we then need to provide a peer address list. So this is basically the actual IP addresses of the nodes as you want them to talk to each other on. So this is very important because if you've got servers that have got, say, like a 1 gig management interface and then a 10 gig interface for your actual production traffic and so on, you'd want to be using the IP addresses from that 10 gig interface, not the 1 gig management interface. So make sure you get that right. But it's just a simple list of IP addresses separated out by commas. Now, the MTU, or maximum transmission unit, is very important because we're using tunneling. So I don't want to go into much detail about this because, yeah, that's an interesting rabbit hole in itself. By default, it's set to auto. In some of the forums I've been reading, it doesn't work. The idea would be that it should be able to automatically calculate the MTU based on the underlying network and so on. But yeah, I think the safer side is to actually manually put in the MTU. Now, this is going to vary depending on your own network. Typically, the MTU is 1500. If you're using jumbo frames, we're talking probably 9,000, but you'd have to check. In any case, we have to actually deduct 50 bytes because that's going to be allocated for the tunnel overhead. So I need to change this to 1450. For the nodes, well, by default, it's going to allow this to be used on all of the actual nodes, but you can select the drop-down menu and pick out individual nodes if you want to restrict it. But in this case, I'm just going to leave it to run on all of them. IPAM, by default it's set to PVE because that's installed, but it's not going to work in a VXLAN zone anyway, so it doesn't matter. I mean, if you've predefined this to support other, say like third-party solutions, you could use that as well, but that's a whole other video in itself. So at this stage I can't make any changes here, and even though we're not actually going to be using IPAM, I can't really deselect that option, so I'll have to leave that as is. Now, I've just deselected advanced because if you select that, you can also set the DNS server, the reverse DNS server, as well as the DNS zone. So this is extremely useful if you're using IPAM, because what it means is that you can have sort of global settings for these, but you can be more specific for certain zones. So that's very, very useful when you've got it's like a large network, or I suppose even a small network, and you're considering using different DNS servers for different actual network zones. So yeah, definitely useful to have, but for the sake of this demo, IPAM doesn't apply, so it doesn't really matter. So I'm just going to click on add, and that creates our actual VXLAN zone. Now the next thing to do is to create a virtual network for our virtual machines. Now to do that, we'll click on VNets. Then down the left we've got VNets, and down the right we've got subnets. So the idea is that you can have one or more VNets, and each VNet can have one or more subnets. So what we do need to do is to create a VNet, so we'll click on create. Now what we want to do is to give this a name. Now I'm going to call this network 1. It would be better to make this something more meaningful, as you'll find out later, but one thing to bear in mind is that you're limited to 8 characters. The good thing is you've got an alias or description field which can store a lot more characters, so that'll be helpful if you want a better understanding of what, say, like this network represents. We've then got to assign this to a zone, so I'm going to click on the drop-down menu. I've only got one to pick, so I'm going to pick that one. Then we need to provide this with a unique tag. So I'm just going to give this a tag of 10,000, but there is a very big range to pick from. It doesn't really cover this within the Proxmox documentation, as far as I can tell. If you have a look at Cisco's documentation for VXLAN on their devices, you're looking at 1 to 16 something million, but this is standards based anyway, so yeah, you've got a lot of flexibility. But again, it's got to be unique for every VNet that you actually create. Now, to keep things simple, I'm not going to make this VLAN aware. I'm just going to click create, and that creates the VNet. Now, to set up a subnet, which would make more sense when you're actually using IPAM, but for the sake of demonstration, what we're going to do is we're going to click on that actual VNet, and then click create to create a new subnet. It wants to know what the actual subnet is. So basically it wants the network address inside a format. So that is the actual network address for this example, 192.168.50.0, and it's a /24 network. You'd then be defining the actual gateway. If you're going to be using SourceNAT, or more specifically, you're going to get Proxmox to do SourceNAT. So that's translating the actual source address into something that the actual Proxmox server has. Then you could do that, but I prefer to leave this sort of thing to firewalls anyway. Just like any other DHCP setup, you've got an option to put in a DNS zone prefix that would get handed out as well. And then we've got our DHCP ranges that we can set up. So in other words, you can set up multiple ranges. To do that, you would click on add. Now, you've got to provide the complete IP address for the start as well as the end. So in other words, you can't just put in the 4th octet. So even though the first 3 numbers there are all the same, you've got to have the complete IP address, which I suppose makes sense if you're using a /23 network. It would get a bit confusing then. Well, which of those 2 parts are you talking about? It would just get too confusing, I think, for the developers to try and figure out what's what. So yeah, it makes sense. They just forced you to use the complete IP address, and you can add multiple ranges if you like. Now, we don't have any software installed on this to support Proxmox handing out IP addresses through DHCP. It won't work anyway because we're using VXLAN. So I'm just going to take this part out, and I'm just going to leave this in for the sake of reference more than anything, because maybe somewhere down the line, if this feature does get supported and we can actually get Proxmox or maybe a third-party IPAM server handing out IP addressing, then this would make a lot more sense and make life a lot more easy to manage everything from the hypervisor here. But yeah, that sets up our actual VNet and our actual subnet that belongs to it. Now, although I've been making changes to Proxmox VE, none of these changes have actually taken effect. If we look here within VNets, you'll see there's a column called state, and they're showing a state of new. If we go over to zones, the state is new. So what we've actually got to do is to apply these changes and get all this pushed out to all of the actual servers. To do that, we'll go up a level to SDN, and then we'll click apply. Now, one thing I'll point out is that at the moment, what we've got is local networks. That's what we've got here. Each of these servers has a local network. So that's referring to the classical network that originally gets set up as part of the initial installation. So that's your typical Linux bridge within Debian that's referencing. But once we click apply, we're going to actually see a new network created on all of these based on what we've done within SDN. So I'm going to click apply, and then off it goes. Essentially, just bring up the task list. It's going to start going through applying all of these changes to the actual servers. So you can see it's starting to create them, and just going to basically wait until it's finished. Now, I must admit, seeing big exclamation marks against things is a bit nerve-wracking, quite frankly, especially if this has been a production network. But it's all now finished. You can see status now is available for these 3 networks. So this is the actual test zone that we created. And each of these actual nodes is now showing a test zone. So we've got the original local network plus the new test zone that we've got. So if we go back to zones, the state on that one's disappeared. We go over to VNets, that's disappeared as well. But as far as we can tell, that's all now ready to use. Well, now that we've got SDN configured and it's been pushed out to all of the actual nodes in the cluster, the next thing to do is to start attaching virtual machines to our actual virtual network. So to do that, I'm going to select this virtual machine here on node 1. Then what we're going to do is go to hardware. Then we're going to select the network device and click on edit. Now, it does say bridge here, and at the moment it's connected to VMBR0. In other words, the underlying Linux bridge that you get with the Debian operating system. But if I click on the drop-down menu, there is our actual VNet. So we don't just get to pick Linux bridges, we can actually now start to pick virtual networks that we've created as well. Now, I did go back and actually add something into the alias just to demonstrate that that does show up here, but we've only got one actual VNet to pick from, and I'm going to select that. Now, the good thing about this is that having a name like that is a whole lot easier to understand than, say, VMBR0. I mean, okay, we've got comments here, but typically with these Linux bridges up to now, you've probably also been using VLANs. Now, you can do that, but we don't necessarily need that going forward with SDN. You can have separate actual VNets for your different areas of the network. So we could have one named sales, one named HR, production, DMZ, and so on, that are a whole lot more meaningful. All you're going to have to do is pick the actual correct VNet here, and you don't have to worry about trying to remember what's that VLAN ID for the sales department or for the actual production environment and so on. It just makes life a whole lot easier as far as I can see. But there is one thing I do need to point out, and that is the MTU, because that has changed. We're using VXLAN and we've got an overhead to account for with the tunnel. So by default it's 1500. It might be something different if you're using jumbo frames, and we need to change that. Now I could type in 1450 here, but when you're using VirtIO here as the actual model for the actual virtual hardware here, you can actually just type in 1. And as it says, this is a special number because it'll actually calculate the MTU from what it calls underlying bridge. So I'm just going to select 1 here, click OK, and now it's just a matter of starting up the actual virtual machine. But in classic Blue Peter demonstration, I'm just going to click this one here because here's what I prepared earlier. So just wait to connect into the console of this one. And if we type in IPA, you can see that this computer, it actually has an IP address. So it's actually learned this through DHCP. And the thing to point out is that the MTU is 1450. So in other words, this computer is also connected to network 1. As you can see, MTU is set to 1. So it's obtained an IP address from another IP DHCP server that's on the actual network, because although we've got IPAM in the background there, we haven't installed any of the software, it's not going to work for VXLAN anyway. So I've had to set up a separate DHCP server to actually hand out IP addresses, which it has actually done. Well, we've now got 2 virtual machines, each of them connected to a different hypervisor, but they're both attached to the same virtual network. So what we want to do is test that SDN is actually working, but we also want to test that it's actually working in the way we expect it to. So this computer that I'm on at the moment, this one here, it's got an IP address of 192.168.1.103, and as we saw earlier, that one is 192.168.1.102. So what we're going to do is just run a basic ping test. So there you go. So this virtual machine can ping this virtual machine, and this virtual machine can reply back. So that's a good sign. Now, the thing to bear in mind is the MTU. So what I want to do is I want to make a slight modification. I'm using -m do because I don't want the actual packets to be fragmented. I want to force it to send a packet size of 1422. The reason for that is because although the MTU is 1450, there's an additional overhead that we actually lose due to the protocol that applications use. So that is the maximum size I can actually send in this case, because if I hit return, you'll see we're getting a response back. Now, if I just increase that just slightly, you'll see we're now getting an error message. So again, although we've got an MTU saying 1450, you've got to factor in you're going to lose a bit more of the actual size because of the protocol overhead. But in any case, we've got connectivity. Now, $64 million question for me is, well, is this traffic actually being tunneled? Because that's the expectation. I'm expecting traffic from this VM to be put into a tunnel. This server sends it to this server pops it out of the tunnel and sends it to this virtual machine. But who's to say that what's actually happening is the traffic from this virtual machine just goes to the server, and the server just pops it straight out onto the network as is. Now, that to me wouldn't be good at all, because you're just mixing all of your actual traffic over, say, like one VLAN on the physical network, for example. That's not what I want at all. So what we're going to do is run a test for that. So over here on node number 2, I'm going to use TCP dump. And basically I'm going to ask it to check and let me know if it sees any traffic in the 192.168.1.0/24 network, because that's what those actual computers are using. So come back to our virtual machine here and start our ping test going. Come back to our node over here. Nothing. Zip. nada. It's not showing anything at all. So that's a good sign. We're not experiencing what I was concerned about, where the traffic is just being sent as is. So I'm going to cancel that TCP dump, and what I'm going to do is just change it to run a different filter. We're going to look out for traffic going to or involving UDP port 4789. So if we go back to our virtual machine, it's still running a ping. Come back here, hit return, and there you go. There's the actual traffic. So I'm just going to cancel that, because if you look at a bit more detail here, you can see that there's traffic from what I've got as a server called demo 1 here, that's that one there, going to demo 2, and it's going to port 4789, and it's recognizing the traffic as being VXLAN traffic. Within that tunnel, we're seeing traffic from 192, 168, 1.103 and 1.102. So these are the echo requests and replies going backwards and forwards. So that's traffic all bundled up within the actual tunnel, just as we are expecting it to be. So that's a very good sign. Here, the fact is that it works as expected. I mean, we've now got traffic on this virtual machine being sent to that virtual machine. It wouldn't matter if these two servers had been in different subnets. As long as they can build that tunnel, we'd still have that layer 2 connectivity between these virtual machines, which is ideal. It really simplifies the whole network process, because we're bringing this up to the software level as opposed to the underlying physical network level. So I can keep on building virtual networks on these hypervisors without having to make any further changes to the underlying physical network. You don't have to pay for very expensive switches and so on. There's a lot to gain from this. Let me put it that way. But one thing I'm going to point out, though, although we know this is working, is I'm just actually going to have a look and see what these servers are up to. So I'm using the SS command with the TUNLP as the parameters here, and I'm filtering it out for 4789, because I want to know what this actual server is listening to on port 4789. And as you can see here, it's listening on all interfaces. So that's just something to point out. When we actually set up SDN specifically for the actual zones, so if we go back to here, we go to the zone here, we edit that, I've got a list of IP addresses. That does not have any relevance to the actual interfaces that are being listened on. The servers are going to listen on every interface on that port. So that's something you need to bear in mind from a security perspective. Gives you more of an incentive to configure the firewall on these servers to actually restrict that to where it's only necessary. So yes, we are telling it what IP addresses to connect to essentially, but it has no impact on what interfaces these computers are going to listen on. I mean, if we go down to, say, options, there's nothing here that I'm seeing to let me filter that out. I can't just say, well, can you restrict this a bit? Can you only run this on this specific interface? I mean, I can see the simplicity here. They're just going to listen on every single interface that this computer has. So yeah, just bear in mind something like that from a security perspective. It's not ideal. You want to lock that down. But the good news is, yeah, it works, and it's pretty easy to set up. Now, one thing to point out is that we've been setting up virtual networks using VXLAN. So we've got virtual machines on these computers here, and we're connecting them together through virtual networks. So that's great if you've got just virtual machines talking to each other within the cluster. But at some point, these virtual machines are going to need to talk to something on the actual physical network and beyond. Well, in that case, if we're talking about connectivity to, say, the internet or computers in a different subnet, well, that's pretty straightforward. We can stick with the usual strategy where we've got a virtual machine here, which is a firewall. And in this case, I've got a firewall that's got one connection out to the actual physical network, so it's connected to VMBR0, but then it's got another interface connecting it to our VNet network 1, as I called it. Now, this should be able to also provide access to the internet. So if we go over to this virtual machine here, we can test that from there. So just see if we can do an apt update for this computer. So yeah, so it's talking to the actual Debian server, so that works fine. The thing to be thinking about though is that what if you've actually got physical devices and virtual machines that are actually in the same VLAN, for example? That could be a bit challenging. Now, I haven't seen any mention of connecting these actual nodes up to, say, switches that run VXLAN. But having said that, I'm not sure if that's a path I'd want to go down anyway, because part of the appeal of this software-defined networking is to remove complexity and cost, more than anything, of the actual physical network. It would probably cost a lot of money to pay for switches that support VXLAN versus your typical off-the-shelf switch that just supports VLANs, for example. So that's something to think about. In which case, well, if you've got, say, access points, so these are physical devices that are in the same VLAN as, say, a virtual machine acting as the controller, then maybe just stick to the normal approach where you use the classical network to give direct connectivity that way, although there might be alternate options here within the software-defined networking. I mean, there is an actual VLAN zone in here, but that's beyond the scope of this video, because here we're just talking about the VXLAN zone. Hopefully, you'll have seen that VXLAN zones are relatively simple to set up. We should expect more capabilities in the future, but at this stage we don't have access to the inbuilt DHCP server or IPAM solution for VXLAN zones. Having said that, we also have the potential of using third-party options like Netbox and PowerDNS. But even just a basic setup like this allows you to simplify the underlying network design, allowing you to be much more agile when it comes to managing virtual devices in Proxmox VE. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.